Why, hello there. Uh, Welcome to my little stream about demo scene and crap. And today is the fourth episode for the fourth season of this demo scene stuff, where will be going through my latest, our latest intros that we made in the past months. And well, the stream will be in English for some reason again. Привет, Медвдев. Привет, Владислав. Привет, Ирина. Привет, Остров. Привет, Содинг. Привет, Кин. At least I have some viewers. So yeah, as usual, if my main language today is English, I will be still switching sometimes to Russian if I have Russian comments, Russian questions, but I will try to stick to English, and this will be horrible, of course. As usual, my English is not that great. So, a backstory for today's stream. Basically, in the past months, we managed somehow to release 4 intros and even took a few winning spots with the demo parties. Привет, НП Сипкрю, наверное. So, in chronological order, the first intro that we made was название, which is like it. This started when we tried to work on an 64K intro for assembly, and basically I failed to make any content in time. So yeah, as usual, all of these intros were made like a couple of days before the party, on which they were released. So yeah, it was really, really quickly done as usual. Есть низкий поток. Есть, можно на ютубовский линк зайти, вот тут где-то ссылка, YouTube длинная ссылка вот такая, но в общем там автоматический реинкод на более низкие эти самые. Так, и вот это, наверное, так можно сделать. Hello, Xavier. Sorry, I have trouble pronouncing your nickname. I hope it's fine. So yeah. Well, the last intro, this Posle thing was made actually in the past. I was started making it on Tuesday, I think. So it took like 4 days to make, but it will be late. I will tell the story later. All other intros were made, like the Posle was made with me on vacation. All other stuff was made where I actually had to work, so I spent only like a bits of evenings on them, and like Friday evening and like half of Saturday or whatever, like the usual. So okay. So this название, I think it was our first attempt at 64K. So we tried to make a lot of... Kin tried to work on using the 64 clan synthesizer to make himself familiar with it. And I tried to make something that is not really size constrained, because 64K is a lot of space. It's like unbelievable amount of space. We ended up making like it was about 40K in as the end result at the executable file that we submitted to the party, and we didn't even think about size limitation. Like we didn't minify shaders. The code was like C++, really straightforward C++, and yeah, basically the only thing that we did that was like there were two things that were that had something to do with optimizing it for size. Is like first thing is Kin used 64 Clang, which is size optimized synthesizer, and we used K-Crunchy to compress it, and that's it. So yeah, another thing that it was made, usually I made my intros on Linux using like this live coding tool, like whatever iteration of my live coding tool that is current at the moment. But this one was made actually fully on Windows because there were text in it, and I just couldn't be bothered to write the same some implementation like for text rendering in Linux, and yeah, I had to make it really quickly during the single day before the deadline. So yeah, I'm actually starting to forget, like it was a lot ago, it was a month ago, and I started to forget all the little stories that were there when we were making it. So yeah, let's start with me showing you this intro. I will be showing you the video files because I have trouble making my frame rate, my screen capturing frame rate is suboptimal, let's say that. And then when I will be showing you code, then maybe I will be doing some live coding to show things, but we'll see. So this is the название thing. Okay, let me hide myself. How do I do this? So yeah, that's basically it. You're welcome, Xavier. Yeah. Задумался ли на абстрактной теме для демы из поработать с дизайнерами, художниками? So the question is, have I thought about doing something less abstract and working with designers and artists? Yes, in fact, I did, but I don't have any friends who are artists, but who are both artists and interested in demo scene. So basically, I'm all alone there. Yeah, and like color colors for the prime minister or something. These actually both techniques. It's both ray marching and path tracing, and like some combinations of the different scenes can have different rendering techniques. So the idea behind this intro was like, if we are going to try to 64K intro, we should like make something just to try things. And my main thought was, okay, let's just put a lot of stuff there, like many scenes that change, they change quickly. And given that I participated at like live coding thing, maybe I could code a lot of scenes in a short amount of time that I have left before the deadline. So I actually started working on it before, maybe a day before the assembly deadline. So it was initially targeted at assembly, as you can see, like from the repo name. And as I said before, I ultimately failed to do it, to finish it before the deadline. So I had maybe a couple of scenes, but they were like horrible and not really interesting. So yeah. Yeah, I know who you are. Thank you for following. Okay, so hi, by the way, I haven't seen you in a long time. Okay, so we at that point we postponed it for the until Evoke, which was like in a week, I think. So and let me tell you about how it actually works. So there is this. Maybe I should have have a Windows for that to show you the project structure. But yeah, basically it's like this Visual Studio solution with two projects in it. No, it's a single project which has different targets. It has target for a final demo, and it has a target for the tool. And tool is this really simple like shader file monitor or whatever, like that everyone uses. And this is like completely other thing that I just hacked together for this particular intro. So basically the main is a thing that basically copied for our 4K intros. Except like 64 clan is replacing the 4 clan thing, and there's this sleep for whatever reason. I'm not sure. Maybe I had some issues with like sound synthesis lagging behind the intro. Yeah, I'm starting to forget all these things. So, but main different thing from the 4K intro is that it actually has all the rendering code is separated, a separate file. Usually like 4K intro is like just a single C file, which everything like piled to, thrown together. And for this, in this particular case, it's different. So all the rendering stuff is in this video CPP file, which is yeah, usual Xmacro thing to load OpenGL functions on Windows. As you can see, like, I do use a lot of uniforms for various crap. It's unusual to see something like this in 4K intro. It's usually just one uniform, or no uniform whatsoever. There's like separate techniques to get time into your shader. And yeah, there's this use of frame buffers. It's not really that important in this case, but I tried to do a lot of scenes. I wanted to do a lot of different scenes with a lot of different rendering techniques in them, but they were and like a different combination of post-processing effects. But yeah, I only ended up making a few of them. So yeah, this video CPP file also contains main code for the tool, which is like this file polling crap, just hacked together in an hour or two to be able to reload shaders. I won't go into much detail there. Just, yeah, as you can see, like, it's straightforward C++ with some even templates are there for whatever reason. I usually hate them. It's separable program, as it's just a single fragment shader. Yeah, usual stuff that show errors if the shader failed to compile. Yeah, this is basically just a boilerplate. So there's this program class that encapsulates shader program, and you can use it. It's not really very well thought. It's still like, when you use it, you pass your frame buffer size and current time, because this is like really common stuff. It's just just throwing it together there. For unusual uniforms, there are separate functions, well, methods in this class. Почему Vim, а не Emacs? Ну, привычка, нет никаких причин других. So one thing is, you can see that it actually returns the same program as return value, so I can chain these calls. And yeah, this is like compute is just glrex. Just draw this program, because I end up like just doing this single fragment shader rendering there. Also, there's this texture class that is used for a couple of things. It just creates texture, usual crap. Yeah, it binds to the current sampler. Doesn't do anything with that, but there's this separate function to bind to a specific slot. You will see later why is that. And there's this distinction: if the texture is created empty, then it's supposed to clamp to edges, doesn't supposed to repeat, and if it's created with some data, it's supposed to repeat. Another thing that is just quickly hacked together. So there's this frame buffer, as again, it's like really straightforward. Once a bit weird thing is these draw buffers, which is actually needed for whenever you are doing multi-target rendering, where you are rendering into not a single texture but many textures. I'm not sure that actually ended up using it here. I wanted to, but I think I didn't do anything with it. So yeah, there's this code for multiple attachments. Yeah, I'm supposed to like chain multiple attach methods to each other, but yeah, I don't do that. I didn't do it in the end. So yeah, this thing, you're supposed to, if you have your frame buffer active and you are rendering to multiple textures, you need to call these functions with which is supposed to like multiplex your whatever you're writing in your shader, like to the actual like slot of frame buffer. In this case, it's like 0:0, 1:1, 2:2, and stuff like this. And what is new is like different from other things that I did is this font rendering grab. So what I do here is, this is, as you can see, UTF-16 text for UTF-16 string for greetings. Why UTF-16? Because there are a few Unicode things there, which is like Roji comma greeting, and another thing is this end screen, which is like название is written in Cyrillic, which is like is a Cyrillic word for Russian word for title. So yeah, there are greetings. As you can see, like this is just a structure that a label name, which gets converted into uniform name that is passed to a shader. It can have non-Unicode texture and Unicode texture. Then there's font name, font size, and these are supposed to be 0. Basically, it's a slot for the actual text rect, which gets computed when text is rendered. So greetings, title, end screen, and shader source, like a little thing that you may have noticed in the at the end screen is there like scrolling a shader source of this intro. And then there's this init text function which uses Windows GDI API to render text. It's really straightforward. Like create DC, create device independent bitmap with these parameters. The texture size is hard coded because like whatever, it's trivial to do manually and doesn't make any sense like to calculate it from strings or something in this particular case. So we just bind this bitmap to the GDI, and one thing that it does when we create it this way, it actually fills this pointer with a pointer to actual bitmap data, which we upload, which is gets uploaded as an OpenGL texture in the end. So this is like to get text color and make anything besides characters transparent. Это Visual студийный проект, более того, он под Linux не собирается, тут нет make-файла под Linux, то есть я поэтому показываю просто код, и я его не могу сейчас показать активно здесь, на моем текущем сетапе. This is where I create font, and as you can see, like it has a clear type quality. So it does have this RGB subpixel rendering, and actually this is intended. Like when I first rendered text, I decided like I like this, so let's keep it. So yeah, here's that, and depends on then depending on which kind of pointer I have here. It draws simple like single byte string and Unicode string, and then it feels like result in rect. So this is supposed to calculate rect, and this is supposed to draw, and yeah, again calculate rect and draw. And this is like just some debugging crap. And this is a remainder. So basically it draws text, and then another, there are different labels. They all gets rendered in the single like combined text structure, one below another. So this is basically the code that tells the next label to render just below the previous text. And yeah, as each label can have separate font, we just delete the previous font object. If it was like for 4K intro, I wouldn't do this, but in this case, I don't care, just delete it. And yeah, this is just clean. Also, I generate random texture by using the PCG algorithm, which is really cool. You should read about it. Gets really nice noise. I usually do LCG noise for 4K intros if I need to have stable noise, because usual shader hash functions that are like scattered all over internet and used by everyone, they are not stable from like GPU vendor to GPU vendor, and you can end up with intros looking completely differently on like different GPUs. And for that reason, I usually like generate my noise using some kind of deterministic crap for it to be well, deterministic. But the problem with LCG is that it actually has these really noticeable artifacts where your eye actually sees that it has some internal structure, and I wasn't able to figure out what kind of parameters I should feed the LCG to for these artifacts to disappear. So yeah, I tried PCG and I'm happy with it. Currently, probably I wouldn't use it in 4K, but yeah, we'll see. I have a lot of ideas for 4K intros. So yeah, there's this tool crap, which is hi Muzo, you haven't missed anything interesting. If you skip this entire stream, you won't miss anything interesting, I think. It's boring as usual. So this is like some tiny adapter for consuming the file changes, because as you will see in a few lines, each shader program can actually depend on several shader files. So we have to know, like, we have to update all the shaders that depend on particular changed file and like not miss anything there. So it actually, the idea there is just this bold file keeps some sequence number and which is incremented whenever the file is updated. And then we have this sequence here that tracks if we detected that sequence change. So yeah, if it has changed, then remember and tell the caller that it was updated. Otherwise, it wasn't updated. And then there's again templates. Then there's this bold program which can depend on several files. So it has this number of adapters as many as sources. Это OpenGL. Привет, Алекс 1703. So yeah, the polling here is just poll everything. If any of these adapters was updated, if any of the files, which means any of the files were updated, then we just need to reload the entire thing. I'm not tracking any, like, these dependencies are not complicated, just it's one layer basically, many files, single shader that needs to be updated. And if you have some solution that is simpler than this, I'd be happy to know and really like I forgot the word. So yeah, I'd be really interested to know what the solutions are, because this one is the simplest. If you have like a complex graph of dependencies, then I'd say I do something like this too. But yeah, it depends on like what you're doing. And yeah, then just templates is not enough, so there's a macro to that, like templates and macros. Yeah, full scale. Production quality. And yeah, variadic template arguments. Yeah. So this thing is to declare a program. With name this and these names of shaders. Okay. This else is to what? Yeah. So this is the tool. And this is intro. Yeah, list of callbacks is another approach. It's just generally so imagine, like, I dislike callbacks as a concept. Usually I try to do something that is not like, if I try to design something to avoid using callbacks if I can. So for your case, for example, it's not like really important, but it might actually turn out to be inconvenient for big shaders, for example. So if you are changing two shader files, will it result in a shader recompile twice if it detects like both files change in a single frame? Well, it depends on how you're doing things, but And it's not like particular problem, like you don't actually like write on both files and save them in sub 100 millisecond time or whatever. But yeah, it's like one of the designs actually for maybe I did do callbacks for something like this too. Yeah, it's an okay solution. It's just generally it likes this flow. It's scary for me, I guess. So yeah, why this macro? So let me show you. There's not this one. Video. So yeah, this intro structure is defined in the single file, in the single header file. It defines shaders, a list of all separate shader files and shader strings, and then it defines list of programs, which like for each program it defines like program name and a list of shaders that that like get concatenated to be loaded into this program, basically. So it kind of reverse include, like your usual approach to this kind of problem would be like to write this program, like for example, to have something that some shader preprocessor that would include other shader files. So for example, like these terrain objects program could be something like include common GLSL and then include terrain object spread GLSL and etc. But for my particular thing, like it was simpler to just list all the files that should get me the program. And then there's a separate implementation for these macros for the tool. And in tool's case, it loads them from files that are named according to this. And in final intro, these are actually generated. So yeah, there was this. Irina actually wrote this that I really need for some piece of code to be generated by script. I have no idea. Script. So yeah, it's script. And she's actually right. There is a piece of code that generates a shader header based on these macros. So there's a separate thing that generates this header. But I don't remember what it was actually. I forgot what it was. Yeah, there's this shaders inc project that basically reads the video header file and loads all the files that are listed there and writes them as a shaders age. So yeah, there's code generation too. NVL3, hello, let me read your comments quickly. Cronus started with Vulkan API, Apple rolls out its Metal or Metal Kit, whatever. What's so bad about OpenGL? It's obsolete. What technical disadvantage means data technology? Well, there's a lot of legacy crap in OpenGL. Like, it's really complicated in a sense that there are lots of how would I say it? Well, I just said basically there's a lot of legacy, and its mental model doesn't really isn't really close to what actually happens on GPUs these days, as far as I know. So disclaimer: I'm not a graphics programmer. Like, this demo scenes thing is just a hobby that is like that I do in my spare time, which is like really scarce. So yeah, my opinion may be like not deep or not even correct. And like problems, because it OpenGL semantics is not really close to one that is actually to whatever happens on GPUs. Actually, it has to do a lot of like this, and the fact that there's a lot of legacy decisions in it. It ends up having a lot of like validation crap, whatever, and a lot of opportunities to make mistakes when writing drivers. So particular problem that is solved by Vulkan, as far as I know, is to be able to give programmers a tool that is closer to Metal. And then so basically, what I feel Vulkan is like, just write your own GPU driver for your particular thing and avoid like unnecessary complexity of older APIs, unnecessary functionality of older APIs, and like do your thing faster because you don't have this thing that is actually just prevents you from doing whatever you need to do. Okay, and a few of the chat comments are too far away for me to read. Sorry about that. Pavel, привет. Yeah, and Vulkan is not really convenient for sized intros. Yeah, and basically it's as Xavier said, sorry, I need to figure out how to pronounce your nickname. Yeah, it's a problem that you have to, whenever you are looking for something OpenGL, it's you usually will find legacy crap. Like, when I learned OpenGL, I think what really helped me is just to avoid any tutorials and just go for and read the spec. It does, the spec is nice. You suddenly start to understand why it's done this way, and like everything just fits in place. But yeah, it's still like not really close to Metal. Yeah, basically fixed function pipeline is effectively dead, but drivers still have to support it. So okay, we got distracted a bit. So yeah, basically these macros here are to load shaders from files or from the header file that is generated by separate project. And then I have for every scene there are 3 textures, which is like text texture, noise texture, and frame texture, which is supposed like the pipeline here is really simple. The intro frame is generated, is drawn into this frame texture, and then post-processing shaders get it to the screen. This frame buffer screen is just a dummy frame buffer that corresponds to no frame buffer, but like back buffer for the window. And this is actual frame buffer which corresponds to this frame texture. And then there's this video neat stuff, which is lots of OpenGL functions on Windows as usual, generates all the textures, allocates the frame texture, creates screen dummy frame buffer, creates an actual frame buffer, generates noise. If it's a tool, it loads all the shader files, and if it's not a tool, it's loads all programs, and then it if it's a tool, it loads. As you may remember, there were text label for the shader source, and if it's a tool, if it's not a tool, it just it's read from the variable with this shader source, and if it's a tool, it needs to be a little of I forgot the word, sorry. It needs to read it basically from a class, because this is not a simple variable, string variable. It's this file. And then it creates, generates text and uploads it to texture, and I use blending for smoothing the past tracing scenes. And then there are a lot of crap like this, and I will read chat now. I don't know about full screen windows. Windows here are opened using 4K method, which is like completely not what you're supposed to do on Windows. So yeah, there's this function render pass, which is gets time, current target frame buffer, and shader program that's supposed to render this frame. Apart from usual common uniforms, it actually sets global time, which is needed for to distinguish. There's one shader program that is used for 2 scenes, and I need to distinguish which scene is that based on global time. Because this is like the simplest method that I thought of like 2 hours before the deadline. And although this is for scaling, actually past tracing here is rendered at the half resolution, and yeah, I need for obvious performance reasons, so I need to tell shader, post-processing shader that, and I need to bind the textures. So here's this slot thing, and it binds corresponding textures to this slot, which is like incremented, like really trivial crap. And then I also need to pass a uniform text label uniforms with regions, with breaks that say that this string, that this name is actually this rect in text texture. Yeah, no problem. I just having chat on stream is always gets you into conversations, and it's okay. It's what happens, and sometimes I'm happy with it. Sometimes it's just okay. I can't remember if there was time when I wasn't happy about that. So yeah, basically there are. Each scene is this separate function, draw opening, which is opening scene. And like this sets completely unnecessary uniform. I don't think that I use it anywhere. I think I ended up not using it anywhere, but it's just it's an intro. And I didn't have to worry about size. So there's this render pass which rendered this tunnel program, and then it does this blitter program, which is like post-processing and draw it to screen. And all other scenes are like that. So render some program, in this case like terrain objects, to frame buffer, and then bleed to screen. And it'll, yeah, it's like this: box null, tunnel, greetings. Interesting. If last scene number. Yeah, so this is to switch blending on only once, but I'm not sure why. Yeah. The idea here is that basically path tracing draws a scene. So this is a main reason why I have frame buffers here, because like besides the fact that I wanted to do some post-processing, it's not really, I don't really use any of that in significant way. But here's the thing. I do blending for path tracing scene with previous frame, and actually whenever I draw the first frame of path tracing scene, I actually need to draw it with blending disabled in order to completely redraw the previous frame from previous scene. Otherwise, the new path tracing scene will look too blurry, like for a few moments, because it will blend with the previous scene, and this doesn't look good. And so the first frame of the path tracing scene is drawn without blending, so it completely rewrites the previous content of the frame buffer. So yeah, this is why it's there. And yeah, it also has this end uniform, which tells it what scene is that. Yeah, draw tunnel is not used anywhere, I think. It shouldn't be. There is no separate tunnel scene in the party version, in the released version. So yeah, metaballs is the same. So it's the metapath ball scene. There is this fox cape and screen. And that's it. So the paint, this is basically structure. The paint function is, again, for if this is a tool, it pulls all the shader files and programs. If it's not, it doesn't do anything. And then there's this definition of which scene takes how much time. So basically, my time here is in ticks. It's not in seconds. It's in music ticks. So it's BPM dependent. Yanamaran, thank you for following. And this is the macro to just calculate if the time is less than this number of ticks, then draw this scene and return. And yeah, remember which scene was drawn last. If it's not, then subtract this time from this scene length from the time and increment scene number. So basically opening scene is on for 128 ticks. Same for terrain thing. A box nail, which is like this, which is this thing scene. Yeah. It's shown for 256 ticks, and Metaballs is also so -8 ticks for some music synchronization reason. Greetings is the longest of all of them. And then again, Metaball scene. So yeah, this is the same scene, but which is different. Like you can see this scene, and then there's again the same scene. And yeah, that's it. That's all intro code, like native code. Shaders. Shaders, there are a lot of them, and not all of them are actually used. So first of all, there's this common thing which defines a lot of common crap, like uniforms and labels. So yeah, basically it's synchronized manually in C++. It's not really this tool is written like in maybe 3 or 4 hours, just for me to be able to write something in 64K. Something more complex than 4K, so I can have many shaders and many scenes. But basically, yeah, I didn't have any time to write any like timeline code or whatever, and for some reason I didn't use Rocket for this. Main reason being I tried Rocket a few years back and I didn't like it. But yeah, Kin has shown me current version of Rocket, and I think it became a lot better, and I should try it. But at this point I didn't knew, and yeah, I just did everything manually. So, but yeah, in C++ the synchronization is only for like scene duration, and all other synchronization that there is in shaders, which is like was live coding and is not that it's still kind of interactive. So yeah, this common GLSL thing is a lot of just basic, really common stuff, like all the noises, all the like fractal noise and whatever. Common distance function that I use, and like yeah, ray, sphere, intersection, some other helper crap. Look at is nice. Like coordinate glitching, which is this thing that you can see whenever this yeah, basically std leap. Yeah. So what I need to do is like I don't remember which shaders are there, so I need to consult this table. So yeah, there's this blitter thing that was supposed to be post-processing stuff, and it's empty. Some random stuff. Привет. А там программинг есть уже? Сейчас попробую. So the question is why I'm streaming under creative and not programming on Twitch. And I'm not sure. There wasn't programming when I started streaming a few years ago. So yeah, I've updated to be programming. Let's hope that it works. Thank you. So yeah, what it does, it basically reads the frame buffer texture, does this grab. So this is reading from frame buffer texture. This chromatic aberration thing, some manual synchronization with music, and the scaling for past tracing scenes, and gamma correction, and yeah, there's a lot of yeah, and horrible vignetting, yeah. Grain, yeah, no grain, past tracing is grain. So can you see? So you basically can see that it's half resolution. Like these pixels are visible. Not much for this scene for some reason. Yeah, maybe this thing is actually full resolution because it's really simple. So let me actually show you this thing. Which is greetings. Does it have anything? Yeah, it's not. It's just greetings, right? So yeah, there are a few camera positions based on time. Yeah, I will get to the cut metaball scene in a moment, just in a moment. So greeting scenes, because like first thing that I scene that I built were greetings. I just it's this scene is actually based on a scene from a movie, and that movie contains shader live coding. It's a movie about VR or something, and there's a bit of shader live coding there, and the movie itself is so I'd say, but it was the first thing that the first movie where I noticed shader live coding in the movie. Yeah, the scene, spoiler, cut metaball scene is past tracing, and it's a past tracing with ray marched bolts. I'm sorry for that. There's a cable that I started forgetting which, sorry. So yeah, this scene, the greeting scene, is basically the boilerplate for this scene. It started with this, and it's really trivial. Like you see that there are 1, 2, 3, 4, 5 walls, and these walls are like this has procedural textures. These have no textures, and this is real texture from like this scrolled with emissive colors, and this thing is like more complex version of that scene plus March metaballs. And basic structure is like for 16 samples of for each pixel, for 16 samples of the pixels, start like from scratch, from some camera position, and do 4 ray bounces. Like do 3 ray bounces, because like the first one is just direct ray. And like this plane 1, plane 2, plane 3, and stuff like this, like many planes. And this one I think is the the var one with greetings. And like this, there's a lot of math to calculate the. This is mask for there's there's this grid, like LED grid effect, which is like this masking thing, as far as I remember. Then there's this glitching of the coordinates to read from texture, then read labels, either end screen or grids, and scroll it with this time. And it also like it should have emissive colors, which gets this nice effect. And this is basically the only lighting in this scene. So all the lighting are these characters and these random moving stuff in the background. There are no lights there. And then it's like usual path tracing, where ray you bounce ray. And in my variations, really simple. There are no like sampling. I don't know how it's called. Like basically the ray is either there are. So basically, first, whenever you hit a point, you calculate the reflected ray, and then based on roughness you just noise it, so mix some random into it, and that's it. So there's no like clever math there, it's just this really simple approach, and this gives you this so this is a lot of random and this is less of random. That's it, that's all there is. And this one is to so when you mix some random into ray, you may end up with ray going into the same geometry. So I'm just flip it if it's like going against the normal, and that's it. Кекарка, привет, спасибо. So yeah, that's it. So the next scene, this metaball scene, is based on the same code. It's the same, mostly, and it should be metaballs, but it should have some pre stuff, I think. Okay, let me common metapath balls. Yeah, that's it. That's all there is. Okay. So yeah, turns out that's all there is. So this thing has a twist, which is like let's mix some ray marching into this. So as usual, there's this distance function, which is 3 balls, one, this length minus R2 and 3. So they have this S1, S2, S3 offsets, and they have all the same radius. But they are not mixed with min. They are mixed with this ORND thing, which is not random but round. And this is in common shaders, common GLSL ORND. This is this function. So basically what I do is I'm not doing the usual metaballs with 1 divided by R or something. I tried that. I actually tried that, and I tried it to tweak it to look good, but for this particular scene it doesn't for some reason. So I couldn't make it work. I tried for maybe an hour or two. So I ended up using this function, which is basically mixing between 2 distances, which is HDSDF. I read about this function here. So basically it's, yeah, union round. This is it. Genpaku, thank you for following. So yeah, that's it. The idea here, I'm probably not qualified to explain it right now. So can I explain? I think what they are doing here is like they imagine both of these distance function as axis, and then do this smooth thing between them or something. So yeah, it's safe to say that at this point I don't know how this works. I did like figure it out at some point, but now I forgot and I can't remember. And yeah, just this is some black box, some magic that works, and I'm happy that it works. So thanks Mercury for that. And yeah, so this is like metaballs thing, and there, if they are supposed to be cut, which is this. So yeah, then they are cut. So the cut plane is like rotated. There's this thing is pre-calculated somewhere here, and if it's on, then I just cut it with like max and minus something. Repeated planes with some SP cut based with. So how do I mix all of these into path tracing? Really simple and straightforward. Which is, I do know. So basically, besides Raymarshall, this scene is like this XZ plane and this XY plane, which are really, really cheap to calculate analytically. Intersection, like, it's cheap. It's really cheap. You just divide the distance by dz or something. So Raymarshall is so yeah, here my first attempt was to just I do ray sphere intersection with all of these spheres, but kind of larger. So if we don't hit anything that is any like area with probability to hit these balls, we just don't try it. So there's this estimation that maybe we should like retrace Raymarshall. So as usual, there are two nested loops. And привет, Боча. С удовольствием, но мне еще 3 интро надо объяснить, я не знаю, когда я закончу. So yeah, metaballs there are fake. I tried to do them. Well, how do you call like fake metaballs? Like, it's not like sum of 1 over r over like distance to the ball, because I couldn't make it work, not for performance reasons, but because of like I just maybe I forgot some detail, but I couldn't tweak it to look good. I'd say it like this. There were issues with the normals and some crap like that. But otherwise, like, it looks like metaballs, and it's like, yeah. So yeah, basically, if I hit the area that can be seen, like it's sad that I don't have this intro compiled at this moment, because I could look at could show it live Can I make it work quickly? No, I can't. I will spend about half an hour porting this to Linux. Sorry about that. Or maybe I can make it work. No, I can't. There's too much window dependencies here. Arg. Okay, so I do. There's no analytic form for. Well, I don't know of any analytic form for metaballs, but I do actually do ray marching here. So if I hit the these spheres, think of these spheres as the bounding spheres. So the spheres are around these. They are larger than these metaballs. If I hit them, then I should ray march, and then it's just regular ray marching. So I do 30 steps. It's enough like to step around the edges of these, and it's just usual ray marching, like usual. You start with this bounding sphere. You don't march from camera. You are already there. You know that you are already somewhere close to these balls, and you can go from here to Elmin. Why is Elmin like that? Maybe I just forgot. No, I don't even check it. Right. I don't even check for that. So yeah, I just ray march. So it's not. Yeah, it's like these are metaballs. There are a few artifacts maybe you can see here, and this one is a bit weird. I noticed that after I submitted this because like again it was like made really fast. So yeah, and this ray marching is inside the path tracing loop. So whenever I hit something here, hit the metaball geometry, I do the usual like color calculation. I do roughness, I do emissive, which is like these bands of color, and yeah, and I just store this L distance, and then I also checked again the firewall and just rewrite all the colors if the firewall is closer than, it shouldn't actually happen. Yeah, it's like it's really dumb and straightforward, and I'm not clever. There are not clever techniques. It's just do it. Like this is where I feel a lot of this imposter syndrome. Like, guys, I can't do anything cool. It's just I do the same shit. Like I do the same. I haven't invented anything. It's just the same combination of the same. So yeah, Later intros like calc for KS construction and Postli for function, they use like straightforward ray marching for geometry. Calc uses the same thing. You may remember that the calc is usually the same two planes. It reuses a lot of this, and it actually reuses the same thing for the metaballs. We'll get to that. Like, it's all the same. It just adds another scene with the room and cutting holes from the room, and it also adds like, okay, I have a lot of space left. Let's add like atmospheric scattering there. Yeah, thanks. Okay, so, and that's it. That like, then you can see that the this is actually the same LED code from the greeting scenes, but it's warped in central symmetric way, or like, how do you call it? Like, it's spherical coordinates or whatever. Yeah, it's just it's just like this, and yeah, and then it's basically the same. So do we need to, like, this is mainly two main scenes of this, and I wanted to make a lot of other scenes, and I didn't. So this is actually like just a filler scene that I just, okay, I need something that's right, some repeating cubes, and just throw in them and make them reflective, and okay, I'm not really happy about this scene, but yeah, here it is. This scene is another just random idea that I had. Let's just, a lot of objects float above the height map, and this is actually one of the ideas that I wanted to do as a live coding for the final live coding on revision stage. Basically, when I went and I started my landscape, I thought, okay, I want to do like floating objects above this landscape, and halfway through I completely forgot, and I was like, okay, I wanted to do some specific thing, and I forgot what, and I tried to remember, and I didn't come up with anything else, and yeah, so basically it's just, I wanted to make something like this as a revision shader showdown final. It's a point light, yes. It's a point light somewhere here, obviously, and I think for this case, so I have two shading models in this intro. Like, I have three shading models in this intro. One is path tracing, and this simple like scramble the reflecting ray thing, and another one is like this lumber plus blink phone, like this usual simple lighting, and third one is physically based shading. Yeah, area light. Maybe, okay, let's look at it. Let's look at this thing. Yeah, area lights basically look a lot better than point lights, because point lights are not really physical. This scene would be terrain objects, and this is a lot of shaders, terrain objects, pre-march. So yeah, this is actually physically based shading, and I'm not using it well. It's one of these like quickly made scenes. So yeah, this is basically just the distance function for this scene. As you can see, like this is called W4, and the actual distance function W is like it samples it, and that's it. So yeah, it's like it's made really quickly. I haven't. It's crap. Sorry. Terrain objects. So here it is. It's ray trace, PBR sphere light. Okay, let's open PBR. I don't remember sphere light. I think it's actually area light. This is area light. But it doesn't have the geometry for it. So it's calculated when lighting is calculated, it's calculated as area light, but it's not really shown here as area light. But yeah, you can see like in what sorry state this project is. So yeah, it could have been better, but I'm happy that we have submitted something at all. You mean like let me think if I can make it run on Linux. Can I make it run on Linux quickly? Okay, let's just try it. Main thing is this video CPP with C64 tool video CPP. How many changes are there? Can I just replace it? So, chat, do you want me to try to play it in real time? To edit it in real time? But we'll have to write a little bit of C++ before that, and make files. Okay. Okay, let's try it. You know, as you know, like we do have another 3 intros to cover. I could do it another time, but yeah. Okay, let's try. So let me just copy make file from here. So this should not compile because what? Okay. Yeah, Windows H doesn't exist. How should I do it properly? There's this vimdiff tool, but I don't really remember how to use it. Let's try to remember. Project jetlag, assembly, and green. So it's video CPP, and another is jetlag CC tool video CPP. Okay, I don't really remember how to use this. I think last time I used WinDiff was like a couple of years ago. Diff and diff obtain. Okay, I think I started to remember now. So this is okay. Okay, and this one, 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 and this one. I have already ported this thing, but for another intro, so yeah. Basically, all 4 intros were made using this code, this lack of a tool, let's say. Okay, and this is the last one. All other stuff is there for actual content. So I won't touch this. So I will write this and okay, let me just close this. Make labels is not declared. Of course it's not declared, but I can close this right now. Beyond compare. Okay, maybe it's really download. It's like Windows only, right? No, it's for Linux too. Do I have it like oh, it's not there. And yeah. Okay, thanks for direction for this thing. I will look at it later. Merge. Yeah, I heard a lot of nice things about WinMerge, but basically I'm on Linux, so yeah. Label. So one problem with this is that I won't have any text. Patrick, OMG, hello. Do you see any difference between Linux and Windows in terms of speed and performance? Not really. I can say that usually on graphics drivers on Linux are worse than on Windows, but it's like not 100% in, yeah. Mainly, I use Linux mainly like out of habit, and just I like tiling managers. I love that they can do stuff like these, and it's really not convenient on Windows. I tried this Windows thing that tiles them, but it still like doesn't feel the same. Okay, so I need to fix a few label issues. So this init text is not there. this should be like this, right? No, not that command, no. Make. Okay, draw journal is not. Is not. 60 keywords. Okay. I need to do this. Right? Dump and player. Maybe it's player. Oh yeah, I have ported parts of 64K to Linux, but it's in a separate repository and it's not really fully ported. So what should I do? What I use 64K for is just samples per tick and sample type. Sample type is float, samples per tick is 64 player son. So yeah, I can do like this. Then I have a lot of unused parameters. What? No, it's not. It's I made it in the wrong file. Still CPP. And yeah, why is this? What I was thinking. 51. What? Tool. Why is that? Yeah, sure. Because there's no such directory. Let's play. And you don't like that you can't create this dump audio because you need audio row and you don't have one. And you need it for music. Do I have this music somewhere? Okay, it will be complicated if I don't. So I need music in raw format. So one thing that I could do is I could somehow add the ported 64 client to this project and give it all the music data, and then CSSI the music, but it won't really give me the same music because there are porting issues where it doesn't currently read samples. So I guess the most straightforward thing would to just rip the music out of can I? And I don't remember how to do that. FFmpg rip music. Extract audio from video. Yeah, I think this should have enough data. So yeah, copy out audio. How it was a codec. And then I can just open it with no. Can you open it for me? Okay, and then I can do export. I'm not doing this. What? Where's my raw export? What? What the hell? Custom. Headerless and 32-bit float and okay. Right. Okay, and also I need to make sure that the tool CPP is so it reads music raw. Okay, whatever. You don't need anything like this. Let's do it like this and music raw. Okay, and there's this textures issue. Another really funny thing about this iteration of the tool that was really made really quick, that I don't have arrow controls for the time. So what I do here is I just specify start time and end time, I think. Glitch effect is like it reads video memory and yeah. So I specify start and end time in C++ sources and then like recompile the project and work on this particular thing. Next iteration for next intros do have all this functionality, but this one doesn't yet. Can I actually just get the latest? Okay, what if I just copy from... so here I have like this tool CPP, and then I have jetlag CC tool CPP. Does it have this? So yeah, it has like time shifting capabilities. It does have music row. Does it have anything else? It doesn't have samples per tick. Which is interesting. Yeah, it depends on clan for this particular thing. But yeah, maybe I could just really copy it here. Make it will complain about clan not existing. You don't need that. But you need samples per tick. And samples per tick are... Oh. Maybe you failed at reading file. Okay. I renamed it back. So yeah, and there are no textures, no text textures. And it doesn't resize, and then this it does this time glitch, which is not really a glitch, it's specific thing for debugging post, for editing post past tracing scenes. You may see yeah, basically it get this noise because without that time glitch just writes the same pixels with the same noise. So yeah, what we wanted to edit this one, right? Shaders, terrain objects, and retrace material, sphere light intensity. So yeah, I can make it like 5 times bigger. Make it 10 times bigger. I could make it like light radius. One other thing is that my GPU is glitchy, and if stream goes off, it means like it crashed and I need to restart my computer. Let's hope that doesn't happen, but it can happen totally. Okay, and maybe actually what I can do is I can pause R, which is this thing. No. What? And then this is the initial. And then do I return mean material? No, I won't do it like this. I will do it here. I will do it like this. Crap. Okay, this and length pos L pos R XYZ minus P minus L pos R W. This no. Oh, okay, I need to close this one, right? It's not there. Can I make it? Okay, well. One issue is that it gets wrong color and it gets shadow, self shadow.